Systematic reviews and meta-analysis. These sit at the very top of the evidence hierarchy, so let's understand why, and also where they can go wrong. A systematic review starts with a focused PICO question, and then applies a comprehensive, reproducible, transparent protocol. The protocol is registered up front, often in Prospero, before the review begins. That registration matters because it stops you from quietly changing your question after you've seen the results. Comprehensive means you search everywhere, including the unpublished and the inconveniently negative. Reproducible means another team following your protocol would land in the same place. That rigor is exactly why it outranks a narrative review where an author picks the studies that suit their argument. A meta-analysis is the statistical step that can follow. It pulls results from multiple studies into a single, weighted, combined estimate, which buys you statistical power and precision that no individual study had. And note how the weighing works. Weights are proportional to inverse variance, so larger and more precise studies contribute more. Look at the example. Study C carries 51% of the weight. Study A only 18. It's not one study, one vote. Now the forest plot, and you will be asked to read one. Each horizontal line is an individual study's estimate with its 95% confidence interval. A wider line means a less precise study. The diamond at the bottom is the pooled estimate, and its width is the pooled confidence interval. Here's your rule for interpretation. If the diamond crosses or overlaps the line of no effect, 1 for a ratio measure, the pooled result is not statistically significant. Same logic as any confidence interval, just drawn prettily. Then heterogeneity, which is the honest question of whether these studies should have been pooled at all. The I-squared statistic measures between study variability. How much of the variation is real difference rather than chance? Low values, around 0 to 25%, mean the studies are telling a consistent story. Around 50% pool with caution. 75% and up means substantial heterogeneity, and at that point you should be asking what's different about these studies rather than mashing them into one number. Different populations, different doses, different outcome definitions. High heterogeneity is a signal to investigate, often with subgroup analysis. And notice how this connects back to effect modification. Heterogeneity may be telling you that intervention genuinely works differently in different settings. Finally, publication bias. Positive, exciting studies get published far more often than null ones. So the literature you can find is a biased sample of the studies that were actually done, and meta-analyses can drift optimistic as a result. You detect it with a funnel plot. Plot effect size against precision, and a symmetrical inverted funnel suggests you're fine, while asymmetry with a missing corner suggests small negative studies never made it into print. One practical caveat. Funnel plots need at least 10 studies to be interpretable. Below that, you're reading tea leaves. If this helped, like, subscribe, and share for more.